in this video, we are going to have a look at preparation of diazonium, and at the same time, we are also going to see coupling reaction, which comes under chemical properties of diazonium. So now, what is diazonium? Do you remember the Sand-Meyers reaction in haloalkanes and haloarenes? So it's the same reaction, almost the same reaction. So in Sand-Meyers, what was our mnemonic? We wrote the first four letters capital for Sand-Meyers, wherein our C of the reaction was standing for Cu2Cl2, and S was standing for sodium nitrite, An for aniline, D for diazonium salt, or you can say diazonium complex. Okay, so in aniline, what are we going to add? In aniline, sodium nitrite. So add sodium nitrite on the arrow. Okay, sodium nitrite in presence of HCl. So this will form an in situ reaction. When NaNO2 and HCl react with each other in situ reaction, we get NaCl plus HNO2. Now this freshly prepared HNO2 is our hero. That's what we require over here. So this HNO2, this nitrogen and nitrogen will look at each other. They are old friends. So they will combine with each other, forming N triple bond N. Right? What do they form? N triple bond N. Wherein this nitrogen gains a positive charge. Why? Because it's undergoing overbonding. How? Check. This nitrogen is having 1, 2, 3, 4 bonds, but the right side wala nitrogen is having no problem at all. It's having 3 bonds. It's satisfied. Okay, so now because this is having a positive charge on the nitrogen, diazonia has converted to diazonium. Okay, so diazonium and this Cl minus, okay, which is there in NaCl also. So Cl minus will get attached over here, forming diazonium chloride. So this is the formation of diazonium chloride. Okay, so now diazonium chloride, I call diazonium chloride as the magic compound. Okay, I call it as the magic compound. Why? Because whatever you add to this, likewise you get the products. So we are going to form a total of 9 products from this diazonium chloride. Okay, so whatever you add, you are going to get that kind of substituent attached over here. Why? Because this nitrogen is unstable, 1, 2, 3, 4 bonds. It is willing to break this bond. It is almost made up its mind to break this bond so that it can live a peaceful and a better life. N triple bond N will be more stable. It's the inert gas which is more stable. So as this bond is about to break, whatever you add over here will get attached to benzene at this position. So if you add KCN, you'll get cyanobenzene. If you add water, you get phenol. If you add Cu2Cl2, you'll get chlorobenzene. If you add Cu2Br2, you'll get bromobenzene. HBF4 will give you fluorobenzene. Then Ki will give you iodobenzene. Then HNO3 will give you nitrobenzene. H2SO4 will give you benzene sulfonic acid, and only H3PO4 or H3PO3 will give you only benzene. Okay, so a total of 9 products we are going to form out of this diazonium salt. Okay, N triple bond N plus and minus diazonium chloride. Whenever nitrogen gets a positive charge, we attach it with a suffix called as IUM, diazonium. Okay, so whatever you add, what you sow is what you reap. Okay, so H2O, you get phenol over here. Yeah, and nitrogen gas is released. N nitrogen gas is that N triple bond N, which will live happily ever after. Okay, so here we will get what? If you add H3PO3, you'll get H over here, that's only benzene plus N2. Then if you add KCN, you're getting, as I told you, cyanobenzene plus N2. HBF4, if we are adding, we are getting fluorobenzene. Ki is giving us iodobenzene. Right, all of them are giving you nitrogen as a byproduct. Then Cu2Cl2, chlorobenzene. Let me continue. Cu2Br2, bromobenzene. Okay, plus N2. Then with Ki, we are getting iodobenzene. I think have we done Ki? Yeah, we've done Ki. Then HNO3, nitrobenzene. H2SO4, BSA, benzene sulfonic acid. SO3H. Have we got 9 compounds? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Yes, we have got 9 different compounds using what diazonium chloride. That's why we call it as the magic compound. Then after this, let's move on to a coupling reaction, a reaction called as coupling reaction. Now what is this coupling reaction? It's used for making dyes which are used for coloring. Okay, so that's coupling reaction. I'll write diazonium chloride in the horizontal fashion. N triple bond N, this is N plus, this is Cl minus, diazonium chloride, reacting it with a phenol first. So this is your phenol. Phenol has a hydrogen on the para position, of course. This H and Cl, let it combine and let these two couple with each other. Okay, so we get HCl and copy paste. Yeah, N triple bond N will now become N double bond N, because we got to connect from here to this ring, because HCl is gone in between, from the between, right? So this is para hydroxyazobenzene, an orange color dye. Para hydroxyazobenzene, azo meaning the two nitrogens, they called as azo. With this O, you'll be able to remember that it's orange in color. This dye is orange in color. And you can also do it with aniline. I mean, same, everything remains the same, only this OH will be replaced with aniline, that is NH2, and you get para, instead of para hydroxy, you get para amino azobenzene. Okay, para amino azobenzene, and this is not orange in color, sorry, this is not orange in color, this is yellow in color. Okay, this is yellow in color. Para amino azobenzene, instead of OH just shifted or converted into NH2. In place of OH we have got NH2, and it becomes para amino azobenzene, and that's what is yellow, giving you a yellow color dye. It's called as coupling reactions because both the reactants couple with each other, combine with each other, hence it's called as a coupling reaction. I think we are done with all reactions of amines here.